Hi students, I am Prashant B. Chandran, Assistant Professor, Automobile Engineering Department, SNIT, Adoor. Okay, this is my another video. This video, I am teaching you another method of analysis of heat exchangers, that is NTU method. NTU is the abbreviation of number of transfer unit. Okay, NTU method, problem number 1. The problem starts like this. An aircraft counterflow heat exchanger for liquid metal and air is designed and got the following temperatures. That is, an aircraft counterflow heat exchanger it is designed for liquid metal and air. That is, liquid metal and air are the fluids. Okay, and got the following temperatures. That is capital T1 800 degrees centigrade, capital T2 500 degrees centigrade, small t1 300 degrees centigrade, and small t2 700 degrees centigrade. The flow rate of air is 110 kilogram per second, and CPC is equal to 1100 joule per kilogram Kelvin, and average flow rate of metal is 160 kilogram per second, and CPH is equal to 800 joule per kilogram Kelvin. That is, the mass flow rate and specific heats of both the fluids are given. Overall heat transfer coefficient is given as 610 watt per meter square Kelvin. Find the area required for the above mentioned heat transfer. Okay, use NTU method. This is the question. Okay. Once again, this is NTU method, problem number 1. An aircraft counterflow heat is, it is given that counterflow heat is liquid metal is one fluid and air is the other fluid, and temperatures are given capital T1, capital T2, small t1, small t2, all are given in the problem itself. The flow rate of air, that is mass flow rate of cold fluid air 110 kilogram per second, and specific is given. Average flow rate of hot metal, that is the hot fluid, and its specific heat is given. Heat transfer coefficient is given as 610 watt per meter square Kelvin. We have to find out the area using NTU method. Okay. These are the important points that I have underlined. Please go through it. From the question itself, you have to find out all these. Okay. Using NTU method, you have to find out the heat exchanger area required. First of all, we have to write the given data. I am dividing the page into two, that is 2 columns, that is for a hot fluid and a cold fluid. Here the hot fluid is liquid metal, it is given as liquid metal, and the cold fluid is air. Temperatures of both of the fluids are written respectively, that is T1 is equal to 800 degrees centigrade, T2 is equal to 500 degrees centigrade, small t1 is equal to 300 degrees centigrade, small t2 is equal to 700 degrees centigrade, etc. Then mass flow rate of the cold fluid is given as, I think, 110. Yes, mass flow rate of the hot fluid is given as 160 kilogram per second, and the mass flow rate of the cold fluid is given as specific heat of the hot fluid is given as 800 joule per kilogram Kelvin. Mass flow rate of the cold fluid is given as 110 kilogram per second, and the specific heat of the cold fluid is given as 1100 joule per kilogram Kelvin. And the overall heat transfer coefficient U is given as 610 watt per meter square Kelvin. To find, that is, heat exchanger area required, A is to be found out. Okay, area of heat exchanger, that is A. using this NTU method, that is number of transfer unit method. NTU is the abbreviation of number of transfer units. Okay. Then our solution. Before starting to solve the problem, you should be familiar with a new word, that is heat capacity. Heat capacity, it is denoted by capital C. Heat capacity is nothing but it is the multiplication of mass and specific heat. Heat capacity C is equal to mass M into specific heat is Cp. Capital C is equal to M into small c. That is for hot fluid, specific heat capacity of hot fluid is equal to mass of hot fluid into specific heat of hot fluid. For cold fluid, heat capacity is equal to mass of cold fluid into specific heat of cold fluid. Okay. In this type of problems, that is in problems that is NTU method problems, the first step is to find out the C minimum. That is, you have to find out the heat capacities of both the hot fluid and the cold fluid. From these, knowing these two values, you have to find out which one is the minimum value. Okay. First, heat capacity of hot fluid CH is equal to mH into Cph, that is 160 into 800. 160 into 800, we get CH is equal to 128 into 10 power 3 watt per Kelvin. It is the unit of heat capacity, watt per Kelvin. Then heat capacity of cold fluid. Cc is equal to m dot c into Cpc, which is equal to 110 into 1100. We get Cc is equal to 121 into 10 raised to 3 watt per Kelvin. Okay. The next step is from these values, these two values, which one is the lowest value? That is minimum value. Out of these two values, find the minimum. Here CH value is 128 into 10 raised to 3 and CC value is 121 into 10 raised to 3. That is, here CC is the minimum value. That is, CC is equal to C minimum is equal to 121 into 10 raised to 3, 121 into 10 raised to 3 watt per Kelvin. This is the value for CC, C or C minimum. This is the first step, that is, we have to find out which one is the C minimum. Here Cc is the C minimum, therefore C max is Ch. That is automatically, it comes like that. Then from HMT data book page number 152, that is, here if m dot c Cc Cpc is equal to C minimum, that is capital CC is equal to C minimum. Then there is an equation is, that is the effectiveness epsilon is equal to MC m dot C CC CPC into divided by C minimum whole into T2 minus capital small t2 minus small t2 minus small t1 divided by capital T1 minus small t1. We know that CC MC CPC is equal to C minimum. We know that, therefore that value get cancelled and we get epsilon is equal to T2 minus T1 divided by capital T1 minus small t1, because MC CPC equal to C minimum, both are get cancelled. Okay. Therefore epsilon is equal to T2 minus T1 divided by capital T1 minus small t1. The next step is to substitute the values. Okay. Therefore epsilon is equal to T2 minus T1 divided by capital T1 minus small t1. Substituting the values, 700 minus 300 divided by 800 minus 300. We get epsilon value as 0.8. Next, to find out the value for C minimum divided by C max. Okay. And find out the value for C minimum divided by C max. That is, C minimum by C max is equal to C minimum value we know 121 into 10 raised to 3 divided by C max 128 into 10 raised to 3. We get the value for C minimum by C max as 0.9453. It is C minimum by C max is equal to 0.9453. Okay. Then from HMT data book page number 172, there is one graph. From that graph we have to find out the value for NTU. That is, for from HMT data book page number 172, for epsilon value is equal to 0.8 and C minimum by C max is equal to 0.95. You get the value for NTU as NTU is equal to 3.7. 3.7. Okay. This from this your HMT data book, the y-axis gives the value on the y-axis it is epsilon value is given, and the curve that is C minimum by C max, and if for the value for 0.8 and the curve 0.95, you get the value for NTU as 3.7. Okay. This is the technique. From the graph itself you can easily find out the value for NTU. No other extra calculations are required to find out NTU. Okay. Also, another equation for NTU, that is from page number, data book page number 153. 153. Another equation is there, that is NTU is equal to UA by C minimum. On that equation we can write A is equal to NTU into C minimum divided by U. Substitute the values, that is NTU is 3.7 into C minimum, that is 121 into 10 raised to 3 divided by U is given as 610. Value for area is 733.93 meter square. Okay, it's the value for area of the heat exchanger. Thank you for